Welcome to Jewel Academy, where learning becomes much more easier. My name is Daniel Saros, and today we'll be dealing with this topic, chemical equilibrium.
Imagine you have a bowl of ice cubes. When you leave the bowl outside on a hot summer day, the ice cubes start melting and turn into water. This is the forward reaction, where solid ice reactant transforms into liquid water product. Now, let's say you take the bowl of water and put it in the freezer. The water freezes and becomes ice cubes again. This is the reverse reaction, where the liquid water reactant transforms back into solid ice product. Before we continue, don't forget to subscribe if you are yet to, and also give a like. Thank you.
Without wasting much time, what is chemical equilibrium? As the name is, equilibrium meaning equal. Now, for those of us that are familiar with chemical reaction, you know that two reactants are actually combined to form a product. And as the reaction is proceeding, we should know that it's not every reaction that we see that actually forms product entirely. That means if reactants react, they do not entirely form product. And there are also other reactions that occur in such a way that they occur in either ways. It's either in the forward or in the backward direction. So this kind of reaction by which the reactants are not completely formed, the reactant does not completely decompose to form the product, or they occur in either way, they are termed as reversible reaction. Now let's consider this. A of A plus B of B is reacting to give C of C plus V of D. And also this one, that is, these ones are the products and these ones are the reactants. They can react back to give this. Now, we can also look at these in examples of substance like water. For example, water, let's use this to represent water. We know water is made up of what? Of hydrogen and oxygen. So when hydrogen and oxygen react, it gives water. Sorry, let me remove this. Sorry, remove this. It gives water. So this is a kind of reaction that can occur. Now, if I condense a vapor, which of course we believe might be a combination of this, it can give me water. And at the same place, if I heat or I pass water through a process called electrolysis, it can dissolve back to give me oxygen and hydrogen. So this is a reversible reaction. Now, simply put, a reversible reaction is a reaction that can occur in either way. That means the reactant can react to give product, and product can also react back to form the what? The reactant. So this is called a reversible reaction. Good. Now, having that at the back of our mind, now as these products are reacting to form, as this reactant, are reacting to form this product, it reaches a time where the rate by which the two reactants are reacting to form the product, it reaches a time where the rate by which these products are decomposing to form this is the same rate by which this one is reacting back to form this reactant. So at that rate, if the rate by which this is reacting to form this becomes equal to the rate by which this one is reacting to form the other side, we call that an equilibrium state. Now, for the forward reaction, I will say let's represent a constant Kf to represent the forward reaction, while for the reverse reaction or backward reaction, let's use a constant Kr. Now, the rate of the reaction is proportional to the concentration of the species involved in the reactions. So that implies, from our mathematics, if we want to do this, we'll have our rate will be equal to, let's say we are dealing with A and B for the forward reaction. That will be what? K, which is my constant, F, then with the product of the concentration of this and this, that means the product of the concentration of A and the product of the concentration of B. This bracket here is trying to tell you that it's concentration of A. So this is for the rate of forward reaction. Then for the backward or the reverse reaction, we have the same thing here. Rate will be equals to, instead of using Kf, we say Kr, and what is involved here? C and D. Now, if we check, I put some little alphabets behind each. Like let's say we have this 2H2 plus O2 is giving you 2H2O. So let's say we have this. This is the same thing as 2 moles of hydrogen is reacting with 1 mole of oxygen to give you 2 moles of water. So with that, these 2 will represent this. And because 1 will multiply anything to give that the same thing, we do not use 1 here. So this is the same thing as 1 of oxygen. That will represent this. And so for the rest of the side. Now I'm going to do that. Now in this case, the rate will now be equal to the concentration of A raised to the power of that number of moles that is beside it, which is what? A. And that of B raised to power, what is there? B. Do the same for here, C and D.